Can you guys hear me at the back all right if I talk about this kind of volume? We're good? Okay, should we get started? Okay, so make sure this is working. Yeah, good. Okay, so today we're here to talk about tech debt. I would presume that the fact that you're all in here, you all know what tech debt is or some idea, but we will go through a level of definition on it. I'm not going to give you a solve for it exactly, but I'm going to hopefully try and make you think about it a bit differently. It's something that gets a lot of airtime in engineering teams. I've found it's like often a typical topic of contention and frustration, particularly amongst the engineers, and I'm going to try and talk to how I think we can help that and make a better job of it. I guess I'd like to start does that all sound familiar to you, right? Is it like a common problem in the teams that you work in, you find that you're talking about and getting frustrated with tech debt quite a lot? Yeah, I can see some nodding heads. So what I'll do today is I'm going to talk around some topics around tech debt. There'll be some sort of fundamentals that I put into play, that I talk about just to sort of set the groundwork up. I'm going to talk about how we manage tech debt, how it relates to risk, and I'll talk about risk a little bit. And I know like risk can be a boring topic, right? But I'll try and make it a bit interesting. I'm going to try not to bore you all to death. And I'm going to talk about like how we can do risk better a little bit, because I think that that's probably one of the things. It's got a bit of a bad rap. So a little bit about me. Yeah, there we go. So I'm Matt Whetton. I'm the Chief Technology Officer at Oakbrook, or Oakbrook Finance. There's my social media links and whatnot on there. So if you want to ask me any questions or read anything, then have a look. I consider myself a software engineer at heart. I'm a fairly technical CTO, and I like engineering, and that's sort of where my passion is. I'm also really passionate about comics. So as you can tell by the backdrop in here, that kind of theme will be threaded throughout. So I'm going to be unapologetic about that. But if you want to talk about comics as well, we can go and do that afterwards, right? Because I'm really into Marvel comics. And the last thing, I probably should talk about my boss, the person who kind of tells me what to do all the time. And that's my cat Monkey. Okay, so again, I can't promise that some of this presentation isn't going to be themed around that too. So I was going to frame this talk or this speaking engagement around the hero's journey. Have any of you heard of the hero's journey? It's basically like a sort of a storytelling trope that, it tells the tale of a hero. It's like a common template about a hero that has a call to adventure, has to overcome some challenges, maybe gets to a revelation, that goes through a transformation progress and then goes home transformed and takes that back. So I kind of wanted to do something similar to that, again, because I'm a comic book nerd. So I called it the tech debtor's journey. We're all tech debtors here, I think. And the first bit is the call to adventure. You're all in here, so you've all heard the call to adventure, so I don't have to do anything on that because you're already in the room. The next bit is some threshold concepts, so the basics of getting into this. We're going to just cover some basic things that I think we need to understand in order to have a proper conversation about it. Then we're going to go on to challenges and temptations. It's more challenges than temptations, if I'm honest. I couldn't think of any temptations to insert in there. But effectively, I'm going to challenge you a little bit, and we're going to challenge ourselves a little bit around how we think about it and what we can do about tech debt. Then we're going to have the revelation. This is going to be, actually, there's got to be a better way, and there is a better way, and we can start to attack it. And then we'll go on the transformation. So we'll look at how we can actually develop that out and what we could do. Again, I'm not going to be giving you a pre-canned solution to all this, but I hope it's something for you to think about a bit differently and a way to take it forward and maybe attack this problem in your own organizations. And then, we'll get into the real world application. You'll hopefully take something away, and then you'll take it back to wherever you're working or to your open source projects and maybe try and take some of this into that arena. So we're going to start on threshold concepts. There we go, threshold concepts. I apologize for going mad with the animations. I just got excited using PowerPoint. So there's probably there's like 4 basic concepts I wanted to talk about. And I think it's important to talk about them it's not that you all have to be doing these perfectly, but it's it's important that we all understand these basic things and a general approach to how we deliver engineering change in organizations at the moment. And again, I wouldn't expect us all to be doing these perfectly. We're certainly not at Oakbrook. But the first one is Agile Delivery. So I'm not like advocating any particular methodology here. I'm certainly not backing the sort of Agile industry as it's popped up. But really, I'm talking about the core principles around iterative development, moving forward, and improvement. Specifically, I am saying like not waterfall development methodologies. It's really difficult to build it into that, to build what I'm going to talk about into that. I'm really talking about where teams own their own backlogs, the whole team, the team being the engineers, whoever's in that team, including product ownership and anybody else that might be in that team. And there could be other specialists in there as well, like data engineers, there could be delivery managers, there could be analysts, data scientists, right? So it's whatever that team is. There is a backlog, it gets prioritized. So there are some core concepts that, like, if we don't understand those, then, or we don't agree on those, then like it's going to be really hard to have an easy conversation about it. And I'll probably use some of the words interchangeably. So I'll probably use the word PBIs or user stories interchangeably. I might say sprints too, but that doesn't mean you have to be using Scrum or something like that. It's more just, I've been around a bit and I can't control my mouth sometimes. The next thing is DevOps or no-ops. I'll be honest, I sometimes get confused about the difference between the two, really. But effectively, I'm talking about teams that run their own estate. So we're not talking about handing over to an implementation team. We're not talking about somebody else taking responsibility for your code in production. We're not talking about developers just doing some work and then turfing it. We're talking about you own what you build. Effectively, it's important to tech debt because, like, really, if you don't own what you build, it's really hard to get like a proper, it's really hard to care about tech debt properly, right? Because really, you sort of need to be incentivized to take care of tech debt. So next, I'll talk about long-lived teams. Again, this isn't something that I think everybody has to do, but I'd personally advocate for teams that stick together for at least a year or something like that, or thereabouts. Not teams that are popping up doing some work and disappearing. Again, it sort of fits with DevOps or no-ops. But again, it's about having that longevity and that attachment to the underlying code and the estate that you manage. It's not always best in all circumstances, but it gives time to understand the problem domain and reducing cognitive load. Again, it's about keeping teams incentivized. And then the last thing I'm going to talk about is problems, not solutions. So I won't spend a long time on this, but really it's about the team finds the solution, including the POs. The team gets a problem, they work through it and find a solution. Normally a PO or the business representative in there will come with they'll find the why. Why do we need to do this? The team will know how to do it, but we all agree the what. And I might use the terms, us and the business a little bit. I try to avoid it, so I apologize if I do it, but it's going to come out of my mouth at some point. So I just wanted to talk about what is tech debt. As you've all probably heard of it, it was a term coined by Ward Cunningham. Ward Cunningham was one of the original signatories or sponsors or members of the Agile Manifesto. There you go, you can see the arrow pointing to his name there. He also is credited with inventing the wiki. So he's a smart bloke. He's definitely a techie smart bloke because he's got a beard. But I think we can all agree that he knows what he's doing. For a formal definition, I pulled this one sort of from Wikipedia or Techipedia. I followed some links and found like a decent definition, but it effectively talks about a concept in software development that relies on the implied cost of additional rework caused by choosing an easy solution. So the sort of key things to call out here is that it's the cost of additional rework. So there's a cost involved because you took a shortcut kind of thing. I think it's a pretty solid definition. But again, let's just get the grounding out of the way. So really, what I wanted to say is that, tech debt is really a metaphor. It's not really a thing. It's not a thing that exists, and that's what I'm going to try and convince you on today. It's a metaphor, and actually I think that originally when it was termed, and a lot of the people like Martin Fowler, when they originally spoke about it, they talk about it being, the cruft build-up or almost like limescale build-up in your code over time that slows you down. But I think it's become something a little bit worse than that, and I think it's because it's up for interpretation. I think it's because tech debt's a very techie subject, and engineers generally tend to raise it, and I don't think it articulates the impact. So I'm going to talk about that today. So I actually think it's sort of gone from being just something that drags us down to a ticking time bomb. So I'm going to move on to talking about that now. So I'm just going to have to get a mouthful of water. Just have to bear with me a second. Okay, so we've kind of got through the fundamental concepts, and now we're on to sort of the challenges and temptations section. So this is really where I want to talk about really the problems of tech debt. And I'm more specifically not talking about the problems of like tech debt itself. I'm talking about tech debt management and the way that we try and manage it, or the way that I see is trying to manage it today. And I'm going to start to work towards how I think we can better tackle it. Okay? So on the first challenge I'm going to say is we probably need to stop talking about tech debt. And I'm going to justify that. But like the reason I think we need to stop talking about it essentially boils down to it's a techie thing. And I think that when we talk about tech debt, it separates us from the business. And it separates the business from caring about the nature of tech debt. And it ends up becoming something that only engineers talk about. And again, I'll go into the details on this, but I think there's clearly a problem here. And I think that actually, you know, as engineers, I imagine that a lot of us in here are engineers. I think we're part of the problem, right? We're frustrated with getting it done. We're frustrated with getting something done about it. But like we just do the same thing. We just moan about it, right? Or we just get frustrated about it. It's like the definition of madness, right? We haven't changed anything. I just realised I say the word right a lot. I should not have drawn your attention to that, should I? So what I wanted to do, I'm sorry, what I should say as well is that when I say stop talking about tech debt, I don't mean we should stop dealing with it or just ignore it. I just mean like we should stop using the term or use it less. It should be used as a metaphor to explain a concept. It shouldn't be used as a thing that exists. And it is a really good metaphor, and I don't think we should entirely stop using it. I just think we should stop thinking of it as a thing in our backlog. And, you know, the problem, and as I said, I'm going to get into the details now, and I've kind of put an example together so we can talk through. So what I'd say about this is, this isn't a real example of a backlog. I did warn you about the Marvel references, so it's tough luck. I did make this, you know, I'm not one of Tony Stark's associates or anything like that. And I just imagine that this is what a backlog looks like in Stark Manor or whatever it's called, right? But just to back this though, what I did do was I made this, but I did explore some of the backlogs at Oakbrook and I'd seen some in other companies that I'd got, and all of the tech debt items in here were just translations of basically the same thing in other backlogs. So this isn't completely without substance. But obviously, you know, I've got stuff in here about, you know, he needs a mechanism for thrusting his armor into the sky and whatnot and controlling it. But really, we're not really interested in all the features, which we do have. They're the little green ones, or the bugs, the red ones. We're really interested in these ones tagged with tech debt. I was hoping for more of a reaction with the animation there, so come on, guys. So I wanted to zoom in on tech debt, as you just saw. And do these, I suppose the first thing I want to say is, like, do these kind of problems like look familiar as tech debt items? And I find that, like, in a lot of organizations, we do have backlogs with tech debt labeled in them. Not all, but I see it quite a lot, right? And I think I'd say it's common at this point. And some of the things that are in here is, you know, I've kind of got, oh, you know, we didn't add logging into the life support control module, right? We're missing some logging. But for me, that looks, rather than being tech debt, that looks just purely about supportability, right? How do we support this thing without logging? How do we diagnose problems with it and maintain it? And then we have, you know, what we didn't, the thrust control package, we've replicated some code, we've copy and pasted it, we should have it in a shared package. That does look like productivity, and I think that's the closest thing to the traditional view on tech debt that we have in this list. It's about making the code better and more efficient to use. The next one is about compressing diagnostic transmissions to improve speed. Again, is that tech debt, or is that a performance enhancement? And I guess the theme that I'm building through on this is that all of these things the business should or does care about. They care about you being able to support it. They care about the performance of the system. Okay. Next one on the list is reviewing access controls to the body function monitoring. God, I really went to town on this, didn't I? But for me, that looks like, you know, a data privacy thing, right? Not everybody should have access to that. We should have access controls around it. Again, you know, that's regulated for one by GDPR. But again, if you care about your customers and you care about data privacy, the whole business should care about it. It shouldn't just be the engineering team that does. Next, validate the certificate on the suit remote controller. That looks like a security issue to me. If you're not validating your security certificates, then how are you secure, right? Next was enabling mutual TLS on the diagnostic comms. I threw in 2 for security because I end up spending way too much time talking about it these days, and it's always on my mind. Adding a failover thruster, that looks like resiliency to me. I'm sure that if Iron Man was flying through the sky and his one and only thruster failed, he'd like to have a backup for it. And then the final one on here is adding automated tests for the rocket launcher. God, I'm almost embarrassed now when I'm standing here talking about this stuff. I'm the CTO of a company, for goodness sake. But that looks to me to be like a quality issue, right? We haven't done the right level of test. So what I'm trying to say here essentially is that we tend to see a variety of different things with a variety of different impacts fall into the tech debt bucket, okay? So what this sort of tends to mean is the things that fall into that bucket just tend to end up being the thing the devs keep grumbling about, or the things that devs want to do. And actually, I think that's because we call it tech debt. We don't differentiate and we don't tell the business how it impacts them. And what it ultimately results in is it just being the thing that the devs need to do. And we just need to keep them happy. They're getting grumpy again, and we need to feed the troll, right? Or I don't know, do you feed the troll? But this is the theme I'll return to throughout the talk. It's a pretty techie term, tech debt. It's not something that's commonly used for business folk. I think if we all worked in really great tech organizations, if we worked in Google, then it'd probably be fine, but I would guess that most of us don't. We work in good organizations, but not Google. So I'm going to move on to sort of the way that tech debt is typically managed in a minute. So one way that we can think about tech debt is using the technical debt quadrant model. This is something that was put forward by Martin Fowler. I think it's really useful, not useless. Almost got that wrong. I can't call Martin Fowler useless, can I? I think it's really observant, right? It kind of puts tech debt on a matrix where you've got kind of a reckless decision and a prudent decision, like across a deliberate or an inadvertent decision. So it's kind of saying, did we do it on purpose, and was it prudent or not? So in some cases, what this is saying is that actually some tech debt is good. It was a good decision at the time. It was necessary. If it was a prudent decision and we did it deliberately, it's a good thing. Whereas some is very bad where, we didn't even know we were doing it. What is layering? We didn't even know that was a concept. So that's something dangerous to have in there. I think this is really good for thinking about tech debt. I think it's really good for sort of reasoning about and recognizing what's good and what's bad. But I'm not sure this helps us manage it. I don't really think it helps us bridge the gap between the business and the technical folk. I think that it's good for us to think about, actually, that was a good decision or that was a bad decision. It might even be good for us to reason about when we're thinking about introducing tech debt, but I don't think it helps us manage tech debt once we've got it. I am going to say tech debt a lot in this, by the way. There's no avoiding that. So another group, a research group, I think it was in 2014, didn't really like actually Fowler's approach to it. And they came up with this thing called the ontology of tech debt. And they said they thought we should talk about the nature of tech debt more. And I think there was something really strong in that. And by the way, I should say that all of these people, Ward Cunningham and Martin Fowler, I'm not trying to say anything they did was wrong, because I think everything they did and pointed out was really useful. But I'm really trying to get to a practical application for us. I actually think they had a really good point when they said we need to think about the nature or the impact of tech debt. I think that that's something that's important in managing it. But then you look at the ontology, and I'm sorry about the poor quality image as well. It was the best one I could find. But a lot of this is, again, it's sort of talking about the nature of it, but not the impact of it. Again, I'm not sure how useful this is, unless you have different teams that own all of these things. And most of us probably own all of those things within a single team. So back to the original concepts, we have teams that own their own estate. We've kind of got a DevOps or a no-ops attitude these days. We don't tend to hand off to other teams to manage it. Not to say that's always the case. I also think, and again, I'm up for some criticism on this. I think it's a little bit intellectual. right? I think it's a little bit academic. We're looking at here thinking, I could see hours of arguments about, no, that's code debt. No, that's test debt. No, that's architectural debt. And actually, I'm not sure, again, it helps us. Yeah, sorry, I thought I had two things stuck together there. So what I was going to talk about next is the sort of two ways that I think tech debt plays out in organizations. And I've seen both of these. I think hopefully you'll recognize them. But I don't think either of them are great, by the way. So I'll say that from the outset. The first one is that we have the loudest voice in the room. Again, marginally embarrassed that I'm a 40-odd-year-old man presenting a stupid meme like this here, but it made me chuckle. But effectively, you've got the engineering team on one side screaming, we've got tech debt, we need to deal with it. We can't do anything with this tech debt, it's a nightmare. And then we've kind of got the business or the product people on the other side saying, but we just need new features, we need these new things, the business needs this delivering, we need more value. And I think like this is really common, right? I see this all the time. And generally what tends to happen is it's sort of either the most important or loudest voice in the room that wins out. I think it generally results in like some quite unhealthy conflict, or the person who just argues the best. I'm not looking at any people because I've got a bunch of people in here who work with me, so I'm really trying to avoid making eye contact with those people. And they all know what I'm talking about, I'm sure. But really, what I'm trying to say with it is, we're not making a decision about this based on any rationale other than argument. And I don't think that's a healthy way to make a prioritization decision. Again, please do challenge me. By the way, if you have any questions at any point, I should have said this at the beginning, you just throw your hand up or shout out and I can answer that. And I'll try and leave some space at the end to do that too. Is this something that you guys see, you folks see in your teams? Yeah, great. I'm glad. Oh, that's a relief. I was half expecting to say that and everybody go, no, we're great at this. And it's like, well, what are you doing here then?
Those are the captions the other way around.
Right, okay. So the second way that I see it play out is what I call sprint allowance. I know some people in this room operate this model. I don't think it's terrible, by the way, but basically it's kind of almost like it's a developer problem, it's an engineering problem, they just want to do this stuff. Let's give them a bit of allowance each sprint to do it. And then we don't care what they do, but just let them do it, right? Maybe it's a story, maybe it's a percentage of the sprint, but it's like, just let them do one story a sprint to keep them happy. Let them have one engineer working on tech debt sprint to keep them happy, right? Again, I don't think it's terrible because at least we're paying down some tech debt. And sorry, this sort of, the meme there was meant to be sort of like it's a bit of a patronizing face, right? And I find it patronizing a little bit, but I also find it a little bit frustrating that we accept it. And I actually think as engineers, sometimes we can perpetuate this. And the reason why I don't like it is because of the sort of the dysfunction that plays out as a result of it, which I'll come on to in a second. And ultimately what I kind of get to on it is it feels like someone's doing you a favor or doing the dev team a favor, or it's like a reward to do tech debt. And I'm not saying we shouldn't spend time on tech debt. I'm just saying it's almost like, let's not even think about it. Just let the team do what they want because they're going to moan if they don't. That doesn't seem healthy to me. And really, I guess the fundamental question here is are we making the right decisions? Do you all enjoy the backdrops on this as well, by the way? I spent way longer on the slide backdrops than I did on anything else. So sorry, if you don't enjoy them, it's a real disappointment. But ultimately, I think that how can we say we're making the right decisions in those contexts? How can we say, if it's just an argument in the room, that we're making the right decisions? We have no structure or reason to believe that we would. I think if you've got some really smart people and you're really lucky, then maybe you get it right. I think if effectively the team's just saying, we're going to spend this amount of time on tech debt this sprint, how do we know that we're making the right decisions? How do we know that that's enough time or that's too much time? So, as I just said, I think ultimately the result of that is these sort of 4 dysfunctions that I would sort of broadly describe of tech debt management. And I guess like the other thing is that I'm putting the word management in there because I'm not trying to talk about the problem with tech debt itself. We all know that. I think we all acknowledge it. I don't need to convince you of it. But what I need to convince you is that there's a problem with the way we manage it. The first dysfunction that I see is there's not enough tech debt paid down, right? We end up with a spiraling out of control situation in tech debt. But actually, if you look at the points earlier, it's worse than that. Because it isn't just that we're becoming less productive, it's that we're leaving things unchecked. There might be security concerns hidden within the code base that's tech debt. There might be performance or privacy issues. There might be some really insidious stuff in there that's actually existentially threatening to the organization. But because it's called tech debt, we don't really think about it properly, right? So the first problem is that there's not enough tech debt paid. And I think this is the one where everybody's like, yeah, that's the case for us. There's not enough tech debt paid. The next one is the wrong debt's paid. I've seen this, right, a lot of times. We've got an allowance in the sprint. Yeah, just go and do what you want. And the person just goes, right, well, I want to do this thing because I'm interested in that thing. Is it the right thing to do? You know, it's down to one person's opinion at that point in time. We have no structure for working out whether it is. Now, we would scrutinize the hell out of the other work that we do, but we don't do here. And I've seen it quite often that somebody's just picking up, it could be like a pet project, it could be, you know, a different kind of thing, but it often, you know, they probably don't want to pick up the make sure the certificate is validated, because making sure the certificate is validated is a dull and boring thing to do. The next one is that too much is debt paid. Too much is debt paid? That was wrong, wasn't it? Too much debt is paid. Actually, this is, again, sort of, I guess, controversial to this audience, right? But I've also seen teams where we just spend way too much time polishing. Actually, it's healthy to have a level of debt in your code base. If all you ever do is pay off tech debt, you're probably not delivering enough value. And often, I'd say that this is probably like one of the less often cases, right, if I'm honest. But we do see that too much tech debt is paid in some cases. And I think it's important for us as engineers, we have to acknowledge that, right? We have to hold ourselves accountable. We can't be in an ivory tower over this. And then the last one, which is slightly different to the others, I think the first three all sort of are in the similar territory. I just touched on this one earlier, which is paying down tech debt in a backlog is seen as a reward to the engineering team. I find that really frustrating. It really grates on me, if I'm honest. And you're not doing the organization a favor by paying off tech debt, especially if it's the right tech debt. We all want to deliver better products. We all want to be more resilient, more secure, and more productive. I don't think anybody in the room says, you know what, we want to move a bit slower. You know what, we want to be less secure, right? So it's not a reward. But again, I think it feels that way. And as I said earlier, I think that we're part of that problem. It's because we call it tech debt, and we talk about tech debt, and that's not something organizations typically know much about. So I think in all of these cases, they're not great solutions. I would argue. I think we're burying important issues, and I don't think we know if we're prioritizing the right work. And that's ultimately kind of what I'm getting to. So we've got past the sort of challenges bit. We've set ourselves some foundational concepts. We've talked about the challenges that we have with tech debt, and I've kind of challenged you to think about how we contribute to that problem and the problem at large, right? It isn't just as simple as there's not enough tech debt paid. It's the very nature of what we're talking about. So now we're going to move on to the revelation. I presume at this point, right, and do shout at me if you think I'm wrong, but this doesn't sound like a great situation, right? So there's got to be a better way. Again, Star Trek memes for a man of my age is a bit, mind you, I'm probably the only one who was around when this was on originally, right? So, but yeah, there's got to be a better way. And what I mean by that is we've moved to a model more and more where we empower teams to find the solutions, right? That's the first thing. We want the teams to find the solutions. We'll tell them what to do, but we want them to find the solutions. Then the next thing we said is, actually, we want the teams to actually ideate as well. We want them to find the problems. We want them to, have ideas about the different ways that we could find the solution. So we're not just going to tell them what to do. We're going to say, this is the kind of impact or the outcome that we want, and you guys are going to find it. And then we've also got teams now to run and operate what they build. It's not just a case of, write 10 lines of code, turf it, then write another 10. It's like you turf it, but it's still your problem, because if it breaks, you're the one fixing it. And also, if it goes wrong in production, you're going to have to jump on production and stand the box back up, and you're going to have to respond to the bugs and things like that, right? So we have this, we've empowered teams to take ownership of a whole area. And actually, when you look at our engineering teams now, they're almost looking like microcosms of a whole technical organization centered around a particular problem space or around a particular product. But what I think we don't do really is join up tech debt in the same way. We don't think about it in here. And this is really where I'll start to move on to talking about risk. Really what I wanted to say at this point was, I think that the solution is in how we prioritize in general. I think we probably, and the product people in our organizations, will spend some time thinking about how we prioritize, the value added items, the value creation items, and the features, right? The new features, the new things that we want. But we don't really think that we don't think we really prioritize the stuff that falls in the tech debt bucket in the same way. And I guess the other thing I wanted to say is that I kind of think it's your problem as sort of engineers, or our problem as engineers, to solve. And I'll give you my rationale. It may sound like, but we just write code, we shouldn't have to solve this. But the truth is right, we're all specialists. We are, very well trained specialists in the disciplines that we work in. We have to acknowledge that. It's unreasonable for us to expect everybody in the organization to understand the complexities of the code that we write and the problems within it. It's just not reasonable. Otherwise, the whole organization would be specialists in coding, right? So we are the specialists in that area. However, and this is one area I think we fall down a little bit, it's incumbent on us to understand the business model and the business pressures that we work within. Almost every good engineer I've ever worked with understands the business and the business pressures that they work within. They make an effort to understand the business domain and the customers that domain serves. And I think that that's the difference maker. It's incumbent on everybody in the organization to understand the business model. Whilst we are specialists, we don't get away with just sort of shrugging and saying, that's not my problem. So what I'm saying is I'm not saying it's just your problem, but I'm saying it definitely isn't not your problem. It's definitely not your problem, right? And we've got to try and convince the business to stop thinking about it as something that the devs just want to do. And we've got to align our tech debt around the goals and the pressures of the business. So I'm going to talk about that a little bit. And overall, I'd say we've got the power to make it happen, right? Everybody can be a leader. It's something that we talk about, and I don't want to talk about too much about Oakbrook, but it's one of our sort of mantras at Oakbrook is that anybody can be a leader. You don't have to be a manager to be a leader. You don't have to be in charge to be a leader. Anybody can step up and be a leader. Anybody can do this. And all it takes is taking a stand. And those of you that worked with me, particularly when I was an engineer, and some of you are in here, will probably know I was probably quite annoying to people because I wouldn't say I would be obstinate about things like tech debt, but I would kind of argue the case for this kind of stuff. I would argue the case for us thinking differently. And you should argue the case for thinking differently. Don't think that you can't. So yeah, it's your problem, right? So in general, in businesses, I think there's two things we care about. I'm not going to try and give you a masterclass on all of this, but there's two things we need to think about. Sorry, Siri, not you. There's two things that we really care about in business or in product teams or in delivery teams, right? There's only two things. They're very generic, but there's literally only two things that all of our work should be aligned around when we're doing engineering development or almost any work in business, sort of. The first one is value creation. I'm glad I got at least one smirk with that. So value creation is a complicated subject, right? And it's something we could argue for hours about, so I'm not going to try and get into the weeds on it. I definitely recommend, there's a really great book out there called The Art of Business Value. Really good, really worth reading. It's by Mark Schultz, great author, really a lot to it. But effectively, business value doesn't have to be money. It might be money, but it doesn't have to be money. It's basically value that we can deliver to customers, to colleagues, or to the organization. They're all different vectors of business value. Generally speaking, I'd say that business value is linked to the organization's purpose. I did originally write down some business purposes, but I cut them back. But it's effectively like what they exist to do. And generally speaking, they don't exist to make loads of money. Now, obviously, they want to make loads of money on the way normally, but it could be a charity you work for. It could have a different purpose altogether. It might be that you want to be making a change in the industry. And normally, normally they're linked to sort of the opportunities. So you ever heard of, damn, I've given away my next smirk, haven't I? Normally they're linked to like opportunities. Have you ever heard of like an analysis like SWOT analysis, strengths, weaknesses, opportunities, threats? They're generally linked to the opportunities and the strengths of the business. They're like the things that we want to build. It's normally functional requirements. It's normally like, oh, we need this new feature, we need this new function, we need to be able to do this thing. But ultimately it sort of comes down to, on a day-to-day basis, like a hypothesis. And again, this is where I'd try to refer you to the Mark Schultz book there. It's a hypothesis that the business believes will achieve its purpose. So it's kind of like saying, for us at Oakbrook, for example, we want to, effectively change lending in the industry. And we will have a bunch of hypotheses about things that we need to do in order to be on that journey and to get there. And some of those hypotheses might be wrong, but we need to try and do them anyway and test them. So that's one big thing that we should care about. And I would guess that most of what we think about at work and talk about is that thing, right? It's value creation. The other thing is risk management. So I kind of represented that with a little cat on a tightrope, right? So what risk management generally is, it's about identifying, assessing and controlling threats to the organization or things that get in the way of the organization achieving its purpose. Generally speaking, it's not as exciting, but I used to hate risk, right, by the way. So a few years ago when I first kind of got into this role, and I used to have to do enterprise risk, and any of you that have had to get involved in it will know what a soul-destroying activity it can be. But I actually grew to love it, and I've grown to realize it's one of the fundamental, most important things that we need to embrace as technology people. It's generally linked to sort of your non-functional requirements. So it's generally things like security. It's generally things like privacy, productivity, basically all things that can impact the organization's ability to deliver. And I think this is where most tech debt lives. So another animation would like a woo or something like that. The thing that I'll call out about risks, right, and this is the thing we have to realize, is that taking risks isn't bad. Organizations are predicated on taking risks. If we didn't take any risks, we wouldn't do anything. The easiest way to not have a security or a data breach is to not have any data in the first place, right? You can operate zero risk, you just won't do anything. So taking risks isn't bad. And actually, when you look back at Fowler's quadrants, right, he talks about prudent decisions. And actually, it's starting to sound, again, a lot like tech debt, right? Prudent decisions that you're taking, to achieve your goals. It's risks that we're taking to achieve our goals. Actually, when we talked about earlier about some tech debt isn't bad, again, it's that kind of feeling that we're getting from it. But the thing that we need to be really clear about is we need to know what risks we're taking. And again, back to Fowler's quadrants, it talks to it, right? It says the decisions that we make that we do unknowingly and the ones that we know about, we need to know what our risk profile is. We need to know as an organization what our risk looks like. And I'd say that without it, we're making poor decisions, right? And I would guess that most of you don't talk about this a lot. And that's not to point any fingers or to blame anybody, right? Because I think at Oakbrook, again, we're guilty of this. And it's a really hard journey to go on. And I think part of it is because, and I wrote this note on this card and I was going to skip over it, but it's because, risk isn't that sexy. It's not that fun. It can sound a bit dull. But actually, I think that, like many things, we can make it more interesting. Or not just make it more interesting, but there's a lot of things over the years, and I've been around for a bit, so there is some older faces in the in the building today, so you might get this. But like years ago, testing was boring, right? No one wanted to test, and it was one of these things you turf some work over at the end of like a month, and then people would test it, and it'd be like, everybody hated that bit of it. Now we tend to bring our testing into our teams. We automate it. We do it much more frequently, and we make it, I won't say it's necessarily we make it more fun, but we make it feel more useful. And I think a lot of us now are like, actually, we really like writing automated tests, and we really like doing that. And actually, we get annoyed when we don't get to do it. Deployment. Deployment used to be something that was like, we'd do it every 6 months. Again, everybody hated doing the deployments. Nobody wanted to get stuck on that project or get stuck on that part of it. And it was always like really dull and boring or, annoying work. What did we do? We started doing it more frequently, finding ways to do it better and making it more efficient and automating it. And now, I'd guess and I'd speak for our colleagues at Oakbrook, but we have zero deployment stress really, and we kind of enjoy having an automated deployment process. So what I wanted to do is take us back to the backlog. Again, back in Iron Labs. And I wanted to just look over some of these things that we've got in this backlog. And again, I'm touching on it again, but it's the things that we talked about earlier. All of these things generally tend to relate back to an organizational type risk, right? Our inability to support the system is a risk. Our poor performance or our inability to perform to the required level is a risk. The fact that we might have a cybersecurity breach is a risk. The fact that we might breach some people's data or we might violate, people's privacy is a risk. So it's really important that we acknowledge that we think about the impact of these tech debt items, and then we can do things like make it reportable, which is what I'll come on to in a second. And I've kind of come to believe that it's probably one of the greatest tools in our tool belt if we can get good at it. And I have to admit, right, I don't have the perfect solution to tell you today to this. I'd love to come in and say, do this thing and everything will be great, but I'm not going to, because I don't know. But what I can do is I think, hopefully make you think about it differently. And then I think as a community, like we do with open source, like the last talk, we can start to get better at this together. And I think we can make it slicker. So we've kind of got through the revelation bit. We're approaching the end. Yeah, I'm keeping good time as well. That's worked. We're now on to the transformation. So I think the big questions here is how do we make risk a first-class citizen in our conversations, in our teams? And how do we make risk part of the prioritization process? So what I'm going to do is I'm going to give a really quick primer on risk or getting started with risk. Again, I don't want to like drown ourselves in it because it can be quite a lengthy topic. And like any of you that have got into it, I'm looking at Adam because he's been doing loads on it this year for us, but it can really get too deep into it if you're not careful. But I think you can take some simple approaches and make some simple changes or do some simple things that can have an impact quite quickly. So how do we get started with risk? I've kind of laid out a 4/5 step process that I think is pretty straightforward. The first one is you establish your top level risk statements. So we're going to do that in a second. You then adopt a grading system. I'm going to give you one to work with, but again, I'm not going to say that it's the only one or the best one. Then the next one, which is probably the biggest one, is identifying the current risks and grading them. And then the final one, which is probably the most important one, is use it. And I think that at an enterprise level, we quite often get to point 3, and we don't do point 4 very well. And then the last one is align it with an existing risk framework if one exists. I'm not going to talk about that much today, right? Because it's going to be different in every organization. But if you do have something that talks to your board about risk, it'd be really important or really useful and more powerful if you can hook it into that. So it's like a feedback mechanism up to the board. So hopefully that'll be clearer as we get through this. So the first one, I've got some amazing animations in this, by the way, so get ready for it. Not just yet, but they're coming. So the first one is establish top-level risk statements. So what I want to do here is create some statements that are simple. Don't overthink them. Don't try and make them too perfect, but they sort of describe, what the threat is. In this one here, this example, security. Improper security controls results in a loss of sensitive data or availability of systems. It's kind of saying we either breach or lose some data, or we get hacked and our systems go down, or we get crypto jacked or whatever the latest term is for it. Also, what I'd say with any of these is you can come back and revisit them. Like The important thing with establishing the risk statements is don't overdo it. Just have a go and then come back, right? Iteration, back to the agile way of thinking. We iterate over it. Privacy, improper data management practices results in a breach of sensitive data. Again, a privacy example. And then finally, supportability. Lack of or improper observability controls impacts system availability. Again, I'm not saying these are perfect, right? I did literally write these in a couple of minutes. They are somewhat similar to some of the statements we use at Oakbrook, but it kind of just describes a problem space. And as I mentioned earlier, like, again, I kind of give like, I think 5 or 6, or no, 7 or 8 risk categories or top-level risks in what I talked about earlier. They were around things like security, productivity, supportability, quality, privacy, resiliency, and performance. They might be different for you, right? They might be different for you. But to be honest, right, they're a decent starting point. So if you're struggling and you're finding you're getting stuck in thinking about this for weeks, just start somewhere and then iterate on it. The next thing is to adopt a grading system. Now, we can get really complicated with grading systems. You can actually value and put pounds and pence figures on risk. But what I'd suggest, just try and do something simple to start with, because valuing risk can be quite complicated. Basically, the simple one is you have a likelihood scale, 1 very unlikely, 4 it's already happened or is certain. And you can normally put some statement around it that says the likelihood of it occurring in the next 6 months, and you give it a score. The next you say, well, what's the impact of this happening? And you say, again, low impact, and you can put things that are related to your business around what this describes. It costs us this amount of money. We lose this number of customers. This number of customers can't access their system. Then you multiply them together and you get your score. So in this is 6. So a likelihood of 2, it's fairly it's not super likely, but it could happen in the next 6 months. But if the impact of it happening is really bad, so we have quite a high risk score. See, that was good, right? Yeah, thank you, well done. I should have warmed you up to that right at the beginning, shouldn't I? Honestly, some of these things are great. I guess that's where I spent all my time. Adopting a grading system. So then what you would do is you take that grading system and you would look at your risks and you'd say, the first thing we'll do is do an inherent risk assessment. This is to say, if we didn't do anything, if we didn't try and control this or didn't try and put anything in there to fix it, what would be the actual inherent risk? So if we didn't put any security controls in, what would be the impact on the organization? I'd guess for most organizations, it'd be like right up here. A lack of security controls is going to land you in trouble. And then the next thing you do normally with a grading system, which I'll come on to in a second, is you say, well, actually, we do have some controls in, so what's our residual risk? And residual risk is what's our risk at the moment, now we've got these controls in. Now we've done this work. Now we've validated the certificate. So clearly those things reduce your risk. They don't eliminate it. They might only reduce likelihood. They could reduce impact, but again, it's different in every circumstance. And again, as I said, you can get really complicated with the scoring, more scientific, but this is just a simple method of doing it. Then it's about identifying your current risks and grades. Here I took the example earlier of validating a certificate on the suit remote control. We take that, we then say, actually, let's not just call this tech debt, let's categorize this in our security risk. This is a security risk piece of work. Then what we can do is look at all the security risks together and score ourselves in our area that we manage. It could be one part of the product. In a smaller organization, it could be the whole organization. And we say, well, this is what our current risk, our residual and inherent risk looks like in that space. But it gives you something to look at and to say, okay, we know what our risk is now. We know what level we're running at. So I'm sort of approaching the end, but I've just got a couple of things left. So we've got step 4. We've graded it. We know what our risk profile looks like. How do we use it? So the first thing that we do is we put it into our prioritization process. So when we're looking at what items we should work on, we're looking at our product backlog. We're assessing our stories. We say, okay, well, we know this adds business value, but actually, what does our risk profile look like? And should we be mitigating or dealing with more risk? It should be a first-class citizen in that conversation. Actually, you could also say, do we just need to maintain the current level of risk? We don't need to do anything more on it. The second way is that we report on it. And reporting sounds like a really dull term, but actually when you're in an organization, the best way for you to make things happen is to report it to senior management. is to have a report that tells the picture and makes them clear, this is the risk that we're currently taking. Are you good with that? Because if they're not good with that, then it's incumbent on them to help influence the decision making. So what I would suggest is you report on risk disposition at inspection points. And I'll give a quick example in a second of a report. And what I mean by inspection points, if you're not aware, is it's like at your sprint reviews or something like that. You're going to show, well, we've built this new feature. This is the value that we've added. This is the great stuff we're doing. But also, this is the risk we're running at. And there's no point in building all this really cool stuff if it's insecure, for a start, as an example. And also in that same report, you can review your movement in risk. It's got worse, it's got better. We did this work to move risk from here to here. And the important thing with this is that whenever we're doing our work, we immediately want to try and reflect that in the risk scoring system. Okay, so you either want to do that on it could be that probably now what happens is your organization's looking at this every 6 months or a year. You might want to do this every sprint. You might want to do this every day. You might want to do this on every task that you complete. Does this change the risk profile? But it's important that we constantly keep it up to date and we make that less onerous. An example of a report, I just knocked this together and it's way better than anything we use, by the way, so we'll probably start using this at Oakbrook soon, so get ready for it. But effectively, here what I'm saying is we have an appetite for risk. This is what the risk we're willing to take. Some of those risks on there are outside of appetite. We're taking more risks than we really want to as an organisation, so we can highlight that. We can see from last month to this month, we moved our risk, for example, in security from 3.5 to 3 because we enabled mutual TLS on the diagnostic comms. So that thing I've been talking about all along, we finally did it, right? But what it means is it explains the impact of the tech debt, of the risk in your backlogs, why you should do it. And it also explains to the organisation why it's valuable and where the value is. And hopefully what we start to do is all speak the same language around this. And this is something that I'm quite passionate about, is we all need to speak the same language. I think if we want to work in a healthy environment in technology, we have to stop thinking about technology in a silo and as something different to the rest of the organisation. I'll put some other ones in here about, productivity and things like that. I think the other important thing to do, right, this requires you to challenge yourself because it means that you have to think, is it really that important? And what I mean by that is when we're looking at some of the things that we do, we have to be honest and say, actually, I'd much rather be doing the security work because it's much more important to the organisation than maybe that productivity work, which does annoy me, So the last bit, which I spoke about earlier, I won't cover this, but also aligning it to an existing framework. It can be really powerful, really useful if you have an organisation or an enterprise risk framework. Again, I'm sort of hate the word enterprise, but I find myself using it more and more these days. But again, it can give more power. It can make sure that it feeds into it and that it gets reported at a higher level. So basically now we've kind of gone through the transformation and now it's really back into real world application, and you folks taking this away, thinking about it, telling me that I'm wrong or going and doing something in your organisation with it. We've pretty much reached the end of our journey. Is there any questions? And I thought I'd say goodbye from Monkey as well, my cat. And I'm done. So is there any questions? Oh, we've got one. Yes?
Thanks for that. I really enjoyed it. I can see the application. In my team, we've got a feature that's technical depth. It's like measure the visibility of that, so it makes a lot of sense. Whose responsibility is it, do you think, to do the risk? Is it the team's responsibility, and do you have automated tools to help do that? Yeah,
so two really great questions, and one that I wanted to come on to, but if I'm really honest, right, I didn't have enough expertise in it to really talk to. Or I hadn't seen enough of it before, but there's a concept. So I'll answer your first question, whose responsibility is it? I think it's the team's. The team's responsibility to prioritise the backlog. It's the team's responsibility to decide on what work gets done. That's not to say that it isn't ultimately servant to the business and to the senior leadership, but at the end of the day, the team should be the ones that are taking responsibility for that risk profile and reporting it and making sure the organisation is aware of the risks they're taking, and also propose plans and make progress towards improving it if it needs improving. So I think it's the team's responsibility. Now, you could try and tie that down to an individual. I think in a team, what you'd probably find is that you might find that your tech lead is more driving the risk conversation and your PO is driving the feature conversation. But I'm even a little uncomfortable with that, right? I think really it shouldn't be a competing concern on a different scale. I think they should both be talked about in the same space. At the end of the day, if you could get to the point of value and risk in pounds and pence or in customer value, it'd be a really straightforward prioritization decision. Your second question, yeah, tools. I don't really have any great tools. So what we have started to do at Oakbrook is we build our risk management system into Jira. We kind of try and tie it into the stories that we're building, but we're really early days on it. We build like Power BI reports over the top of it and do things like that to try and make it a living live system, almost like living documentation with this system. But actually, I think what's much more interesting is could we do risk as code? And I think we probably could, but I don't know how to. It's really hard to do this bit. But I think we probably could. When we start to think about things like compliance as code, we start to really think about fitness functions. I think we could do it. Now, I just don't have a solution for it, and I don't think I could be talking intelligently about it, but I do think that that's the direction of travel, right? It's to make it instantly available and visible. Does that answer your questions? Yeah. Anything else? Oh, yeah.
Your table about risk appetite.
Yeah.
There were some metrics in there, and I think some of them were the risk grading, but there was also a metric on the appetite. Is that a separate metric? Or?
Yeah, so generally speaking, I didn't touch on this too much because I was trying to skirt through it a little bit to keep time. But generally speaking, your risk, as you develop and get more mature with risk, you'll develop two things. One of them is called a tolerance and an appetite. And I heard a really good way of describing this the other day. And it's a really terrible metaphor, right? So please don't go away and start tagging things with boxing or something like that, right? But effectively, as a boxer or as a fighter, you sort of have a tolerance, right? This is the amount of punches or the level of punch I can take in the face. That's what you can tolerate. But your appetite is different. This is the level that we want to run at, right? This is the amount that I want to get punched in the face, or this is the amount that I've got the appetite to. This is the level of risk I'll take. So what they are is they're not generally a moving thing. They're generally set as an agreement with the organization to say, we all agree that we want to be running at roughly this level, right? And you don't need all of these things, right? There's a ton, if there's one warning I would give anybody here is that don't descend too deep into risk because it's a vacuumous and vast topic. But thinking about things like inherent risk and residual risk, thinking about things like what's our appetite or tolerance, what is the mark in this case, say for productivity, we've got the appetite to run at a 2.5, which looks relatively high, but it's clearly we've got less appetite for running security that high. But still here, we're currently running at 3, so we're outside of appetite. Our productivity burn is quite bad, is what we're saying there. It's more than we want to be running with. And it's a great way to flag to the organization, we're out of appetite here. We probably need to spend some time doing something about this. And that requires time, investment, sometimes, money or people. Does that answer that? Yeah. Cool. Any more questions? Okay, I think we're done then. So thanks for your time, everybody, and thanks for so many of you being there and sticking with me. If any of you want to talk about comics or any of this, I'll be out on the Oakbrook stand, so feel free to come and talk to me. Or about the boss as well. I can tell you about his motivations. Thanks, everyone.